friends, and welcome back to our channel. So let's continue from where we left off. In the previous tutorial, we talked about all of these topics here, and what I would like us to do today actually is to just get us started with working with databases. And of course, as an extra, I would first, of course, look at logging and tracing, and then how we can use M variables, and then we would initialize a database and then try to connect to this database. But what I can already do here is I'm going to move this. I will do like a slight introduction to ORMs with Rust. And then what I can actually do is maybe move this to bring this over here. And then I can move this to, I can create like an extra section in the end here. Maybe at the bottom here, I can have extras. And just so we don't spend, because I think this is really probably going to take a lot of time for us to just look at it. So what we would simply do would maybe do a quick introduction to ORMs, and then we will, of course, do like a very much longer, much more detailed explanation down here. So what I can actually just do already is to come up here and then change this to, let's say, I can call this introduction to ORMs. So this is what I would like us to look at today. So without wasting so much time, let's just jump right in. So I'm just going to come over here to our main file, and so we can actually continue from where we left off in the past. So if you remember, we had all this setup. If you've not or if you're not familiar with where we were already, I'll of course encourage you to go ahead and watch our previous tutorials. Again, I'm going to leave the link in the description if you want to go back. Anyways, we're just going to look at what we have over here and then proceed in that order. So first thing first, login. So what I would like us to do here would be actually pretty straightforward and quite simple as it pertains to Rust. Yeah, so just in case you don't know, maybe just to give some hints. So sometimes actually it's kind of like um, not quite so clear. Again, depends on who you ask what the actual like distinctive differences are between tracing and logging. But what I can say is like, so with tracing more or less, you can think of it as like a process like where we like record application events, for example, could be errors, could be warning, and other like relevant information during runtime. So of course, with the one huge difference what I can say here is, for example, with tracing, this might involve like say capturing detailed information about say function calls, data flow, and other runtime events. And of course it's particularly useful when we want to debug like a complex system, like or want to perform profiling and stuff like that. And but with logging, we really want to like have like a chronological record of what happened in our application, like in the chronological order. So this proceeds this and that and that and that in that order. And of course, you already know it also helps. It makes it a lot easier for us to diagnose and troubleshoot issues that happen within our app. Anyways, without talking so much, I'm gonna go ahead and install some of the dependencies we require to actually achieve this. So I'm gonna come over to Cargolog. I'm probably gonna make this a little bigger, so hopefully you can see it much better. Or maybe I make it a lot bigger. Think this is more than okay, but that's also totally fine. So let's go to Cargo Tomo. And in here, I would like to just add two packages. So this would be for login and tracing. So I need to add tracing, and what I need would be this should be version 0.1, and that should be okay. And then of course I need the tracing subscriber, and for this I need again version 0.3, and save. And now we install our dependencies, and then we can continue. Okay, the installation seems to be complete, and now I can just come over. I can actually just collapse this. We don't need this anymore, and I can actually come in here and then import what we need. So first I'd like to go to tracing, and from here I'm going to keep it simple first. So I need info. So this would be like the log levels, more or less. And these are some of the just the few things I need actually for now to get started. Again, we don't actually need um, so much for now. And so what I can actually do is maybe come down here, and I can already use the info that we imported up there, and then I can see some like starting server at ports. And maybe here I simply, I'll just put it in here, so I say port 8080 like this, and just like that we have logins. So now our server is up, as you can see, and what we can already do is we can actually come in here and import other log levels. So we can actually have debug, for example. We can actually have error, for example, and would we be able to log those depending on the level of the log we would want to log. But anyways, what I would like to do is just go ahead and hook up our login, of course, with our tracing subscriber, and this will actually be the more interesting aspect for me, more or less. So here I can start the tracing subscriber. Of course, we need to import the package, so I can say tracing subscriber. And here, what I would simply need would be the FMT subscriber. This one, that's really all I need. And so now I can actually come in down here and then instantiate the subscriber. So I can say subscriber, let subscriber be equal to FMT subscriber. And of course, this is implemented using the builder pattern. And it's a builder dot with max level. So you get to specify more or less the maximum log level you would want to use. Sorry, of course, dot with max level. And actually here I can specify the level. For now, I can probably say maybe info would be the max log level. So I can say level info. This is what I need. And so now I can just say finish to get the subscriber. And then maybe I indent this to give us some nice formatting. And then maybe down here, I can now hook this up. So I can say tracing subscriber. And now I can provide this subscriber that I have. Yes, I can say set global default. If I want to set this, of course, globally, of course, I can also set this locally within the file. But anyways, I would like to set this globally like this. And of course, this would give us an error back, but for now, I'm just going to expect and say maybe something quite generic for now. I can say something like error setting global subscriber for tracing, something like this. And that's actually all I would want to do here for now. And now if you look here on the console, like we said over here, our max log level now is info more or less. So now this info we have over here, now we actually can see this being logged down here. And if you remember also, we talked about this in the past, and um, this of course has to do with the maximum number of workers, because again, locally I am working with a Windows PC that has 16 cores. That's also why I have 16, like you see here, that is log starting 16 workers. So of course, like I told you again, you have the option of actually setting the max, because I can actually come down here. Maybe before run, I can see with worker. So I can specify workers and I specify the number of workers I want. So if like currently I have 16 cores, if I want to more or less limit this to say 4 cores, then I can say this here. But otherwise, I can leave everything and this should be fine. But anyways, now you can see over here we have like nice login. And of course, with the simple setup, we can see over here, that's all the setup we needed to do. And of course, because we're setting this globally, we'll have it everywhere in our application. So now we can already do things like debug, for example, like I told you already, if you import the different log levels over here. So if you import debug or error, for example, you can already use this to log those things accordingly. Anyways, I'm going to get rid of this for now, and this should be more than enough for what we need to do here. That's totally fine. So without wasting so much time, I would like to, of course, for us to talk a little bit about env variables, and then we can, of course, move over to working with databases. So with working with env variables is also quite pretty straightforward. So for that, I'll need to import the .env package. So I can again add a comment here and say env var. And what I can really do, all I need to do is come down here and put .env. And for this, I need 0.15. And that would be the more should be the latest version, more or less, at least the minor version. Anyways, pretty straightforward. Now I can actually just come over here to our main file, and then I use this .env right away. So I say use .env, and I need .env again. So this is actually a module. And now I can just come down maybe within our main function. The first thing I would like to do, of course, before we do anything would be to come over here and say .env. And then I say, sorry, .env, and I call OK. No, that's not what I want. Come on. That's all I need actually. This should be more than enough. I'll give this a couple of seconds to rebuild, and then we can continue. So now we have everything we need actually, and that's actually all the settings would probably ever need to be able to, of course, read from our env. So now all I simply need to do is to import env from the standard library. So env like this. And now I can simply just come down here after we've set this, and then a simple, all I need to do down here now more or less to be able to, let's say, read from, let's say we have over here a file called .env. I'll need .env, I can say maybe database connection string. So this would be some random string like this, and I can easily, oh come on, copy this, save, come over here, and now here I can actually say from the standard package, I'm already put this, I can go ahead and just use env. So env that's var, and now I provide the key, and maybe what we can actually do is to, because this should return an in or more or less. So let's look over here. We get like either a string or a var error actually. Yeah, but to keep this quite simple, what we can simply do is to expect, for example. So I can say let con. So this will be our connection string. And down here, I can actually just maybe expect example, and then I provide some message here, and then so now I can actually just maybe print line, for example, and then I can already, just to show you, I say connection string is this, and I just pass con, and that's it. And then we should be able to see this locked down here. So because I just want to quickly show you that now we can comfortably read this file from our env file, which is exactly also what we have here. So that's really what I want to show you. It's really that easy working with env files. And what we're going to do right now is to set up a database, and then I can move ahead to show you how we can connect to this database and then start making queries to it. It's really quite simple. So let's go on and do that. So let's continue. So to work with the database, of course, there are a couple of things you can actually do. You can maybe run one locally, for example. But for us, I'm going to make it a little bit interesting. So I'm going to introduce you to Shuttle RS. I mean, they are in no way sponsoring this video anyways, but I just wanted to show you this. So you can just go ahead and sign up with Shuttle and RS. You can sign up, of course, with your GitHub. If you have one, I'm assuming you do. And then all you have to do is set up a new project. So when you set up a new project, of course, it comes along with it. like a shared database, Postgres database, more or less. And this, of course, you can use for prototyping. And this is also what we're going to do in this project. I already created one over here called Easy Dev. This is like more or less like a project which I started. And what I'm simply just going to do is just copy the database connection string, put it in our .env file, and then we can work with it. So again, if you're new to this, I also can quickly show you. So you go to Shuttle RS. Database, for example, let's read a little bit over here about the database. So you can see here, of course, the database which you get, of course, by default would be this Postgres database, which I think is mostly hosted on AWS cloud. And there is also, of course, option for say Mongo, but I don't think this is what you get right out of the box. But again, like I shared, this is a shared database, so of course this is evident in like the APIs and everything. So again, this is more or less for prototyping. So, but anyways, just go ahead, go to Shuttle RS, sign up with your GitHub account. It's completely free. Create a new project, and this is all the three commands you need to create a new project. Um, and then you have your database, of course, created for you. You just copy the URL, and then you are good to go. So let's continue. I have created one, like I said, and now all we're gonna do is just go ahead and try to connect to this database. So I can zoom out a little bit so we have some room. And now what I would want to do would be to actually just start setting things up so we can work with this database. So the first thing I want to do is to maybe come to the roots, and then I create a file, and I can simply call this schema.sql. And this would be where I can just set up like a simple database so we can actually play around with it. So I can maybe say drop table if exists, and I can call this to do's, for example. And now I can actually go ahead and create the table, create table, and I can call this to-dos, and it's just going to be quite straightforward. So it's going to have an ID, which is going to be a serial, will also be our primary key, and it's going to have, let's say, user ID, which is going to be, let's say, a big int, and it's nullable. And we can have like the to-do itself, which is going to be a text, and it's not going to be nullable. And what I can also do is to create another one. So I can maybe simply, I don't even know if I need this for now, but maybe when we run it for the first time anyways, it's fine. So I would like to create the users table as well, and then pretty straightforward. Create table, I call this users. And again, it's going to have, let's say, ID. The ID is probably going to be a text. It's going to be a string. It's going to also be my primary key. And then I need to say a first name, which is going to be a text. That is not nullable. And I also need a last name, which again is going to be a text. That is not nullable. And I need email, again, which is going to be text. I need it to be unique and not nullable. So these attributes of a user, I want them to be provided no matter what. And then what I can do to start setting things up would be maybe I come into my main file. But again, before I do anything, I would like to install some packages again. So I can come over to our cargo.toml. And what I actually need here would be to install the SQLS package. So I can maybe come here and say DB. So under DB, I need SQLX, and I need version 0.7. And so maybe I can also go ahead to install Shuttle shared DB. And again, I need to add some more attributes to this. So I need to provide the version. And version is going to be version 0.47. And features would be Postgres and SQLX. I think this is what I need for now. In the end, I would also maybe we can package our app, let's say as a Shuttle RS app, and that way we can also maybe have it accessible from the internet. But for now, we are doing everything locally, so that's also totally fine. So I'm not give it a couple of seconds or maybe minutes to install the dependencies, and then we can proceed. So our installation is complete, so we can now continue. So I can come over here to auth. We already had a user created the last time, and then let me look at the schema we had now. So we have first name, last name, email, and ID. And I can come back in here. Let's come back into auth. So yeah, our first name, last name. Actually, we now have ID instead of password. And but that's also fine. Maybe just to keep it consistent, I can also come in here and add password. That should not be a problem for us actually. So let's say password. That's totally fine. And now let me come back to auth. So now we have our model, and what I would like us to do more or less would be to use this user model to of course represent our user. Again, I need ID, which will be of type string. Okay, so we have everything we need actually. And so what do we get? Of course, we are getting some error somewhere. That's also fine. We can quickly fix that. And that's to be expected. So let's just say ID. Again, we'll fix this in a minute, but yeah, so we can say string from, and I'm just gonna leave it as this for now. And I can say some random ID, whatever, doesn't really matter. And this is not a bone of our contention for now. So I'm gonna collapse this, and now I would like us to maybe within in the root within maybe utils, I would like to create a file called db. And again, for now, I'm gonna keep it out because I would like us to more or less build on our previous knowledge, and then we can expand on it. And then I don't want to just give you things right out of the blue because again, it might not really make sense to you how they came about. So here I would like to have, maybe before I do, I simply just bring this into here. So pub mod db. Okay, so within db, I would like to have for my users, okay, and I would also like to have for my, let's say to-dos, for example. Okay, and maybe I already make it public, so we don't waste our time actually. So within users, I would like to implement some functions. So I would like to maybe implement an insert. So again, we'll have all of this. Again, like I said, we'll do a lot of refactoring in the end, so there's no need to worry about this for now. So we need a get. So this is gonna take an ID, which is gonna be of so it's going to be a string, and we need to do a delete, and we need to do a say gets all, and we can do an update, for example. And what else? I think that's okay for now. Let's keep it as simple as this, and then maybe also copy the same coming into our to-dos and put them in here. That's totally fine. So now I'd like us to just go ahead and start filling in the um to start filling in the what we need actually to set this up. So let's start with insert. So with inserts, would need of course our user, and the user should this user should be up of our type user model, this one. And again, gets would now return this, return an attribute that is of type user model. It's going to give us an error because we're not returning anything anyways, but that's also totally fine. And delete would again take an ID, delete will take an ID, and get all will return again an attribute, which should be a vector of this, and update would also take this as the input, more or less. So I think this is what the thought process is like. This is what we would like to implement for all of this. Again, the end would have something similar for our to-dos, but let's start the implementation first with our user model, and then we can see how this progresses. So first of all, for all of this, we also need to have access to our connection pool. So I'm just going to call this as pool. And maybe this is going to be like a reference to a PG, common PG pool, this one. And now what we need to do here is simply simple. So again, we need SQLX. And now I need to say query. And I would like to, maybe to keeping it so simple, now I'm going to just do a simple, like a raw query. So I can say insert into users. And this is actually how I can pass the argument for our DB. So let me close this up first, and then I would like to bring up our user model. Where is it? So let's go to auth, this one, and I put it on the half screen so we can actually see what we're doing. It should come over here, and we have a lot of warnings, but of course that's completely fine. We'll fix this in a minute. So for our user model, I like to provide a first name, last name, go away. I need to pass a password, email, and ID. And let me maybe collapse this so we can have more room, and maybe this one as well. And so now what I simply need to do, it would now be to bind with all the attributes that we would like to provide. So I use the bind more or less to, so the advantage of using bind more or less in this context would be that this also helps us to sanitize the inputs, because now we are more or less working with a raw SQL. Again, I don't expect you to think of this more or less as an ORM. It's actually not is in the strictest sense. So, but the bind, it's really quite useful again, because now you're writing raw queries, and then it helps to sanitize the input, more or less. That's the idea. So, anyways, now I can say user dot the first name. I think that's what I'm providing. So first name, and I bind user dot last name. Maybe I close this up for now. So I have password. Again, I bind again, user.email, and then say user.id. And now I can say .execute, and now I provide the pool, and I wait. So let's give that a couple of seconds to recompile. Now it has recompiled, and now from what we can already see, we need to make our function async, and that should take care of what we had over here. And now maybe what we can also do would be to actually let's see what we get back from. So let me just call this res. So let's see what we get back actually. So we actually get back an option, like an enum more or less. We can actually get back a query result or an error. And maybe what we can simply do here would be just to match this. And so here now I can do this. So we have an OK. This would not really do much for us. I can say maybe print line, whatever. And then we would have an error this would be our error. And for now, maybe I also do this. Let me think a little bit of what we can actually do to handle the error in a more efficient way. So of course, I think what would really need to happen here is that we can actually maybe decide to return an error or something so that the user who gets to consume our module decides how they want to handle the error. I think that would be the most efficient way we can proceed in this regard. So we can actually, what we can actually do is maybe remove this match here. And so now let me look at this again. So I say res. So this is what we get back. And now maybe this would actually be what we return back to the user. So I'm probably just gonna cut this part and remove all of this here, and then remove this as well. And then this would be our return statement. Okay. So that if you use this API, if you consume our module, you would already know that you get two things back. One would be this query result, and the next would be an error. And maybe what I can do would be in here to make this a little easier. So we have our query pool, and we have Postgres, and then query PG query results. And now I can just get rid of this part. Doesn't need to be this long. And yeah, that's actually all we need for our insert. Pretty straightforward. Again, this is specific for our user. And now the next thing we would want to do would be to handle. Again, this is really easy. That's all you need actually. Okay, anyway, so let's go over and handle for like when you want to get a user based on ID. So you provide an ID, of course, and then we be able to make a query. But again, I need to copy this part. Because again, we need the connection pool for all of these operations. So I'll copy this again. And again, what you can already understand here is what we can do would be maybe to parse this connection pool, put it in the app state, and then pass it down to our API so that the actual endpoint that needs to consume this would have access to it when it needs to, more or less. Okay, so for our get, again, it's actually pretty straightforward. So again, we do SQLs. And now what we need to do because now we want to retrieve, and then we also need some way to more or less have our structs be mapped to the result we get back. And for that, we need to implement a different, a new, we need to implement a new, more or less, a new threat on our user model. And that's just the row from, I think, 1 second. It's actually, let's say SQLX. Yes, from row, actually not row from. So this is, sorry, this should be the bot, sorry. And this is the additional threat we actually need to implement on our user model. So we'll be able to more or less pass on what we get back from our query into this struct. So we can again say SQLS, and now we can say query as. No, I need to be able to compose this. So I need the function, not the macro. And now I add my query. So my query would be quite simple. So we say select, so what do we want from the user? Maybe we want everything. Let's say first name. Yes, we might not want everything, of course, because we don't want to show the password, for example. So first name, last name, email, ID from users, where ID, I think it's just called ID, is equal to $1. And maybe we can, it's just one thing, so we don't need to do anything further at this point. It's just completely fine. And now we again need to bind the ID that we need to provide. So this will be the ID. And now we can still just call the fetch one function, which is this. Again, we'll pass our pool, and now we await this. So again, let's look at what we have. So we can call this let's res. So our results, why do we have this error? Of course, again, we need to make our function async. So we can be able to, of course, await. So now we have some crazy errors. Okay, of course, this has to do with our return statement. Anyway, so now we can do what we can now do is to annotate the type of what we get back here. So this would be, of course, results. And here would be, of course, our user model. And so now we can, of course, handle the error. So again, maybe we change this again to actually, we just take what we have here again. I'm just going to copy this. And this would be our return statement. And now I remove all of this. Again, it's no longer needed because again, we want the user of our app to be able to consume this whichever way they want. So now I can also remove this. It's no longer needed. And it seems we still have some errors. So let me try to fix that. Okay, of course, here some angle bracket closure is missing. And that's actually all we need to get an attribute. So you provide an ID, and of course, we pass the pool, and then we give you an enum, so either a result or an error, and then you decide how you want to handle this error. It's as simple as this. Again, I'm going to make the rest of the functions async because it's just so we don't run into unnecessary errors and then start wondering why. So with delete, again, all of them would, I'm just going to copy this and put them all of in all of these functions because they would need to have access to them. So get how needs will still need the pool. That's fine. And then of course our updates would need a pool as well. So again, let's start with delete. So for delete, we really do not want to return anything to the user when you delete something. So it's going to be quite straightforward. Maybe the only thing would return would be an error. So I'm actually just going to copy this and put it in here. Simply just change the query here. So again, it's simply straightforward. Here I'll simply say delete from users where ID is, of course, this ID here. And I simply maybe just call execute. I simply call execute on this. And it seems we have some errors. And of course, I change this to query because again, I'm not returning anything back. I don't want to map this to anything. And maybe again, our response would be here like we had before, like this. So I'm just going to copy this again, and this would be what we return to the user. And that's done. It's really that simple. Trust me, it's really that simple. And then for get all, again, this is quite similar to this one here. So I'm just going to copy this and bring it down here. Again, so for this, what we would want to do again is we would see use the query as function. But again, first now what I do more or less would be to modify this. So I can say where this is this, and maybe I add some more things. I can say order by ID, and I think that's really it. And maybe here, just to add the flavor, I can also limit one, whatever, it doesn't really matter. And again, we can use limiting here if we want to implement some pagination, but that's really not so necessary for now. So we do a query as, we'll bind, of course. In this case, actually, there is no ID. So we simply select everything from ID. And then what I'm going to do is just to remove this first bind here because we don't need it. And then now what I need to do would be just to fetch all instead of one, because now I would be expecting a vector back. And then again, let me look at what I get back. So I get res. So this would be, maybe I close this off first. And also here again, I would like to specify what I'm getting back. Again, so if I type this, it's just going to be similar to what we had over here, only that this time would be getting a vector. So I'm just going to copy this, again, remove this instantiation we have over here. So it's just our query. And so here I will replace this with this, but now here, of course, let me remove one of these. So now here, this would not again be in angle brackets. And now because this would be a vector, more or less. So this is what I want to give back to the user, but it seems we have some errors, but let me fix that first. Yeah, of course, we are not returning anything because you are closing this off with colon, semicolon. So if I save this now, this should be fine. So we have our gets, we have our insert, we have our delete, we'll have our get all, and then update. Maybe I will leave this for you to implement, but it should be pretty straightforward. And now what I would try to do is to incorporate the usage of this